This is the integration packet number 7, problem number 5. We have talked about the fundamental theorem and the accumulation function, a of x from 0 to x of f of t dt. And we're asked to find different values. What's the value if x is 3, 4, 5, and 6? In order to do that, you need to add up the squares underneath the function, because we are adding up the area between the function from 0 to some arbitrary x. Those x's are the 3, 4, 5, and 6 in this case. So add up those squares underneath and you're going to get your values. So in B we're asked to sketch the graph of a of x on the graph below. Again, I've talked before about making sure that you recognize this is an accumulation function, that since we're going up to some arbitrary x value, our sketch is going to have x on the horizontal, and we are sketching the graph of a function a of x. So, things to notice. Since between 0 and 4, f of t is a constant function. The accumulation is at a constant rate. That leads to the linear part of the curve in here up until 4. It should be linear. And then on the second part, on the green part on the f of t graph, this part of the graph is increasing. The function's accumulating more area, and it's accumulating it at an increasing rate. That leads to the second part I have here, and you should make sure that that's concave up. Okay, if you take a look at that green part again, and you did some calculations on it, you could see that it's a linear function, and you could find the equation of that line, which I have done. I have found it to be 2t minus 6. That's going to help us with the question in D, and because if I want the value of a of 5.1, well, a of 5.1 is just a little bit bigger. It has a little bit higher value than the value at 5, right? So a of 5.1 is the value of a of 5 plus a little bit more. And I'm going to call that little bit more to be b. Okay, when I drew where my red line where 5.1 is, I was actually off by a value. 5.1 is actually right here. What I have here really should be 6.1. Now the question still remains, what is the value of 5.1? It's a of 5 plus some little bit, plus a little bit more. So if I highlight this section and we think about what we have there, we have our value of the function at 5, which, since f of t is 2t minus 6, then the length here, when it's 5, would be 4. Now if I make this a little bigger, if that's 5.1, really what I have is a trapezoid, okay? And the function value at 5.1, that would be 10.2 minus 6, so 4.2, I believe, would be the height there. Now my delta x that I have down here that's just 0.1, right? So the area of trapezoids is 1/2 the sum of the bases. Now, in our case, the bases are the vertical lines here. Okay, it's kind of a vertical trapezoid. We often see them drawn as horizontal trapezoids. So it's half the sum of the bases, so 4 plus 4.2 times the base. And our base is going to be 0.1. Now if we do that calculation out, well, 4 plus 4.2 is 8.2. Half of that is going to be 4.1 times 1/10 is going to give us 0.41. So that 0.41 is really our value of the b here. So a of 5.1, well, it's a of 5, and a of 5 is 11, plus the value of b, which is 0.41, so it's 11.41. Now, in D, they've asked us to take a of 5.1 minus a of 5, so I just actually added those two together, right? And so the answer for that would be just our value of b, which is 0.41. In part E, they ask us to take the value that we found in D and divide it by 1/10. And that's going to take and move our decimal point over to 4.1. So F asks us to do a similar procedure as we have computed between D and E, but instead of using 5.1, we're looking at a smaller interval at 5.01. So I've given a little diagram over here as to what you're to compute. Okay, I'm going to leave the actual computation up to you, but the value that I got overall was 4.01. Now, you probably remember that as we went into differentiation, we kept looking at smaller and smaller values away from a number. So on G, we're asked to take a similar procedure as we've done in D, E, and F, okay? And instead of making it a specific small number, we're just looking at a value that is from 5 to 5 plus h, where h is going to get smaller and smaller. It's going to approach 0. So in this case, the a of 5 plus h, well, it's the value of a of 5 plus a little bit further, and so I'm going to call that little bit further C. So in our case, a of 5 is 11, and again, that little c value is going to be the value of the area under the trapezoid there. So we're going to say, well, our base is 1/2 the sum of the bases, okay? So the sum of our bases would be the function at 2 times 5 plus h, minus 6, that would be one side, be the longer side, and then we already established that the that the height at 5 is just 4. So we have to take one base, add the bases together. So half the sum of the bases. And then we have to multiply it by the height. Sorry, I really should have said multiply it by the base length, and our base in this case is h. So we have a little bit of computation to do here. And we can say that is 11 plus a half times, well, that would be 10 plus 2h minus 6 plus 4 all times h. So that's 11 plus a half. We have 10 minus 6 is 4 plus 4 is 8 plus 2h all times h. And that would be 11 plus 4h plus h squared. Now again, that's a 5 plus h, and our numerator is supposed to be a of 5 plus h minus a of 5. So a of 5 is 11, so I'm going to have this term minus 11, so I'm just going to have 4 plus h squared. So ultimately, this is still g. It's asking us, ultimately it's asking us to take the limit as h goes to 0 of what we have in the numerator, the 4h plus h squared, all divided by h. Well, if you do that division, you have just 4 plus h, and as h goes to 0, that limit is 4. Okay, so the answer to that is 4, which, if you look back at EF, as my numbers got small, as my delta x got smaller and smaller, my function approached 4. My limit approached 4, and so it kind of makes sense. Now, don't forget what this term means. When you're looking at that, I'm hoping that you are recognizing that as the definition of the derivative of our function at x equals 5, which is what part h is asking. So the derivative of the function at 5 is 4. Now, what I want you to do is I want you to think about, take a look, we were right up here, we wanted the derivative at derivative at 5? Oh, and its function value was 4. That's a big connection right there.